Hello, this video is from Mathematics for Economics. The question is, comment on quasi-concavity or quasi-convexity of the following function. The function is f of xy equals to 2x to the power half y to the power half, where x, y are positive. Now the condition for quasi-concavity. Condition for quasi-concavity is number 1, 0 f of x, that is the first order partial derivative of this function with respect to x. Fx, if xx, this is negative, and number 2, 0 fx, fy, fx, fy, if xx, if xy, if yx, if yy, this has to be positive. Now if we expand this determinant, it becomes 0. Then we are expanding this determinant with respect to the first row. Then minus fx, this into this, f of x into f of yy minus fy f xy, fy f xy, then plus fy open bracket fx into fyx, fx into fyx minus fy into fxx, fy into fxx. This becomes minus fx square. Now I am opening the bracket, fx into fx, that is fx square, into fyy. This minus into minus, this become plus fx fy fxy, fx fy fxy. Now we open this bracket, fy fx fyx plus fy fx fyx. Then we multiply this, it becomes minus fy square fxx. This is positive. By Young's theorem, if xy equals to fyx, this implies minus fx square fyy plus 2fx fy fxy minus fy square fxx. This is positive. Or if we are taking all values on the right hand side, therefore fxx fyy minus 2fx fy fxy plus fy square fxx, which is negative. These are the two conditions for quasi-concavity. We have to verify these conditions for this function. Now the function is f of xy equals to 2x to the power half y to the power half. Therefore fx is what? Fx is, we are differentiating this function partially with respect to x. That means we are differentiating this function with respect to x, keeping y constant. 2y to the power half, then this half x to the power minus half. This is x to the power minus half y to the power half. This is positive because x and y both are positive. Now fy means we are differentiating this function with respect to y, keeping x constant. That is 2x to the power half, we are differentiating y to the power half with respect to y. This becomes half y to the power minus half. This 2 2 get cancelled, therefore x to the power half, y to the power minus half, again this is positive. Now if xy, that is we are differentiating partially with respect to x, fy, this is del of del x, fy is this one, x to the power half, y to the power minus half. Now we partially differentiating, that means we keep y constant, therefore y, first we write y to the power minus half, now we differentiate partially, x to the power half, it becomes half, it becomes half y x to the power minus half. That means this equals to half x to the power minus half y to the power minus half, this is positive. If xy is positive, now we calculate fxx, that is we partially differentiate fx with respect to x keeping y constant. That means we differentiate this, that is fx equals to minus x to the power half y to the power half partially, that is with respect to x keeping y constant. This minus half power comes here, then minus 3 by 2 minus half minus 1 is minus 3 by 2 y to the power half, this is negative. And if y is minus, we are differentiating this function with respect to y keeping x constant, therefore minus half comes here, y to the power minus 3 by 2 x to the power half, this is negative. Now we check the conditions. The first condition is 0 fx if xx, this is equals to minus fx square, which is negative. Which is negative? Why? Because this is a square terms fx square and there is a minus sign, therefore it is always negative. Now we check if xx fy square minus 2 fx fy f xy plus fyy f x square. We are concerned about the sign, not the value, therefore we check only the sign. If xx is negative and if y square is positive, therefore if xx if y square is negative, if x positive, if y positive, if xy is also positive, therefore minus 2 fx if y if xy is negative. This term is also negative. Now if yy is negative, if x square is positive, therefore if yy if x square is also negative, therefore the whole expression is negative. Therefore if xx if y square minus 2 fx if y if xy plus if yy if x square is negative, hence the function is quasi-concave. Since both the conditions are satisfied, therefore the function is quasi-concave. Hence the function is quasi-concave. I hope everybody understood the solution of this question. This is a lengthy mathematics and we do with the partial differentiation. These are the two formulas, the conditions for quasi-concavity, and then we check. We should not put the values, because if we put the values it becomes much more complicated. We are concerned about the sign. Therefore we check the sign of fxx, fyy, fxy, and we get the condition. The function is quasi-concave. I hope everybody understood the solution of this question. That's it for this video. Thank you.